Air resistance. Here on Earth, we tend to take air resistance for granted. We just assume that when we throw a ball, launch an aircraft, deorbit a spacecraft, or fire a bullet from a gun, that the act of traveling through time our, through our atmosphere will naturally slow it down. What is the reason for this? Just how is air able to slow down an object, whether it is a free fall or in flight? Because of our reliance on the air travel and our enthusiasm for space exploration and our love for sport in making things airborne, understanding air resistance is the key to understanding physics and the integral part of many scientific disciplines as a part of a subdisciplines known as fluid dynamics. It applies to fields of aerodynamics, hydrodynamics, astrophysics, and nuclear physics. Air resistance definition. By by definition, air resistance describes the force that are in opposite of the relative motion of an object as it passes through the air. These drag forces act opposite to the oncoming flow velocity, therefore slowing the object down. Unlike other resistance forces, drag force depend directly on velocity, since it is the component of the net aerodynamic forces acting opposite to the direction of the movement. Air resistance is the result of collision of the object's surface with the air molecules. It can therefore be said that the two of the most common factors that have a direct effect upon the amount of the air resistance are the speed of the object and the cross-sectional area of the object. Both increases speed and cross-sectional area will result in an increased amount of air resistance. So in this video we're going to go through some example for finding the air resistance. So air resistance would be so typically we're gonna find out the air resistance with car, that how much air resistance is upon a car when a car is driving or cruising along a street or a road. So first of all we need a formula for that. So the formula for finding the air resistance is RA equals to, we got 0.5 from the formula, and then rest of the formula we have 2.15 or 2.15. we have, this is also from the formula, and we have a rho, it means the density of the density, and density of the air would be considered something like that, and another is CD, the braking distance, and then A is the air the cross-sectional area of a car, and U is, we have U for finding the speed of the car, and then divide by gravity. So suppose we have a passenger car, and it's moving with a speed of 65 miles per hour, and the cross-sectional area is 40 feet squared. So when as I said that A is cross-sectional area, due to that it's a square, and the foot is square, foot square, and we have the rho. So the density, the rho would be, the rho is always 0.766, and the braking distance, depend on the car, that which kind of car is that. So as I said, passenger cars, for passenger car it is 0.4, for trucks it is from 0.5 to 0.8 depending on the car and how much axle that car has. And gravity, as you know that the gravity is 9.81. So we will change that to foot. So the gravity would be, when changing to foot, it's 32.2 foot. So we have all the things, and now we'll put all the things on the formula. Like the RA is equal to 0.5, 2.15 rho. The rho is times the rho is 0.0766 times. We have CD, the braking distance. The braking distance is 0.4 times A. A is the cross-sectional area times 0. It's not 0. It's 40. It's 40 times U squared. It means the speed of the car. So the speed of the car is 65 miles per hour squared divided by G. So G is 32.2. So when we multiply and divide all those things, we will get, so when we multiply all those things, or the air resistance would be RA equal to 172.9 lb. So when we divide all those units of them, we will get the finally lb. So as I said, it's a air resistance, so it's a kind of a force that aerodynamically acts on on objects. So due to that reason, it is measured by lb or Newton. This would be the. So here's another example. Suppose this time we have a truck and it's going with a speed of 105 miles per hour. It means the U is equal to, wait a second, the U is equal to 105 miles per hour, and we have the aerodynamic. It means the aerodynamic of the core is 42 feet squared, and that's all we got. So we have to find out the rest of the things that we require for the solving and finding the air resistance. So the formula that we had, air resistance is equal to 0.5 2.15 times rho times CD times aerodynamic times the speed of the car, and all these things divided by gravity. So we have we'll see that what we have and what we don't have. So 2.5 rho. So the rho, it means the density of the air is always 0.0766. It's always, and the aerodynamic, we have that. And the braking, it means the CD, the aerodynamic of the car is it means the CD is equal to, as I said, it's a truck, so the truck you typically is 0.5 up to 0.8. so for now you're getting that 0.5, and we have the speed. So let's put all these things on the formula. 0.5 equals to 2.15 times the rho we have is 0.0766 times CD. That means the aerodynamic of the core is 0.5 times A. The cross-sectional area is 42 times the speed is 105. It has to be raised to the power 2, and all these things divided by gravity. We have, so the gravity will change that to foot. So when we change that, it's 32.2. So when we multiply and divide all those things, the gravity, the final air resistance we'll get would be that's 473.66 or 66 lb. So air resistance is a kind of force, so it's measured by lb and other units that we require for the force. So that's all.